Hi, I'm Andrew Armstrong and welcome to the back of this show. If you watched my earlier video on reflow ovens, you will recall this device, which was the giant LED clock that I previously put together by hand over the course of at least 2 videos. That didn't quite work. There was a little bit of an issue, but I can safely say after the reflow video it's probably not going to work again. So at least we've reached a conclusion, 100% conclusion on that one. I thought it'd be interesting though, just to have a quick look-see to see what the damage is, because it's quite amusing. There are sort of amusing damages here. So first things first, of course, a number of components have just sort of flopped off. They were so hot and the board was at a slight angle, they just slid off, literally slid down the board straight off. The solder's so molten, the PCB substrate's so hot, it's just literally like water on a sheet of glass at that point. But we'll zoom in though and have a look at the the more interesting features. So first things first, delamination. So this allows us to have a look to see how the PCBs are actually constructed. So they're actually made out of this material. I can't remember the exact name. If you look on PCB sites, is it called FR something? It's a fiberglass basically. It's a fiberglass resin board, very hard, very rigid, very flat, and that's coated in copper. And that's the copper you see that's removed using various techniques, generally some sort of acidy type, erosion to get your traces out. It can be printed using optical techniques or lasers or 3D printers, I suppose, or plotters if you want. There's all sorts of ways of actually drawing onto the board and then using chemicals to sort of take that off. So that's the very thinnest layer there. When you think of PCBs and electrical signals, that's what it is, and that's all it's going through, like the thinnest piece of tin foil that's sort of glued to a board. So that's why you can see there, these boards are relatively thick, but they're quite hard. So when you're drilling through them, that's why your drill bits, if you ever work with manual tools on a PCB, blunt very quickly, because it's literally glass fibre. And glass fibre is hard. It's like drilling through glass. In fact, it's quite good. While I'm here, I can use this to nicely polish up the end of my tool. And you'll see this now, and I just sort of take the dust off it. You might see it, and maybe not. But it's really nice and polished and shiny. It's like a file, this material. So first things first, obviously some components again that have moved and slipped out of the way. That's pretty much standard though. If the board's not sitting flat, you might get some movement, and that's certainly what's happened. What's happened is the board wasn't particularly level to start with, and as components on the bottom half melted, the board tilted, and then you can see the components have moved off. And I did have a quick little feel around of my tool here while it was still molten and sort of popped off some of these resistors. Again, it took me a long time to make this board by hand, but only a few moments, literally 2 minutes to destroy it. So yeah, that's pretty standard on that side, not too much interesting stuff to see, but here it again is something a bit more amusing. Look at that LED display. I don't know if that will work again. We could try powering up this board. I suspect it's not going to do anything. The LEDs on the outside have definitely got a slightly brown haze to them. They've not enjoyed the colour. The speaker here has sunk into itself. It's very much become shorter, sunk into itself. ICs though look pretty good. I mean, they're not going to be made out of melty stuff. They're basically made out of sand. They're going to be pretty much indestructible, as are these sorts of resistors and things. I mean, most of these passives are probably okay. I mean, you could probably just take off these resistors and use them again. There's no problem with that. But I don't think these tack switches are going to be usable. They've certainly they look more like LEDs now. No, they're not going anywhere. Crystal probably is gone out of spec now. This electrolytic though is slightly bulgy, but probably okay. But unlike this electrolytic, which has totally basically blown up. There was something that blew up while it was running. I think it's probably this electrolytic. Probably what counts for the acrid smoke in the room. The actual material of the board here has melted through these vias. You can actually see there some of those through-hole vias or actually those are pins, have actually just melted in on themselves. Again, nothing too, you know, I think for a lot of it electrically, this board probably is not too bad. You can see it's got that kind of bubbly effect, which just looks a bit like the old microcomputers where they used to put the lacquer on top of they tin the board and then put the lacquer on top of the tin. It was something like that, and it had that weird bubbly effect. But yeah, I think electrically it's probably pretty good. You probably could just pop the components back on and fire it back up, but if you recall, there was something wrong with this board originally, and there's certainly something wrong with it now. So I'm more than happy to actually put this in a bag, and yeah, if you're interested in it, let me know and I'll post that along to you. And if you could salvage it, I would be friggin' amazed, to be honest with you. I think we all would, but you're welcome to try. I'm going to pop the little components back in there. So that's a shame. It's a shame I didn't get it working, but it's also a shame we didn't get to see a proper actual reflow. But I'm going to revisit the old reflow thing. A little bit embarrassed that it died. I don't know what I did to the settings. I wasn't paying much attention. Of course, reflowing something with a lot of components still on it is probably bad news anyway. Give us some advice down below if you're a reflow expert. Tell us, how would you take this? If this was a PCB from a laptop with a graphics chip that desoldered itself, what would be the technique? Just maybe watch the old temperature, I think. I think this would have gone up to about 300 degrees C, which for a little board like that, yeah, I guess it's just too much. Anyway, thanks for watching.